Okay, now we're going to continue with adding these fractions, but now we're going to add some whole numbers in here with our fractions, so we'll deal with some mixed number pieces. Now when I do this, 5 and 6 are the bottom numbers. We're still going to focus on changing those. So 5 and 6, if I think about those numbers, I'm going to have to change those so that they have the same bottom number over here. Now notice I've skipped a space. I did that on purpose because I want to make sure that if I skip a space here, I have a spot to put the 1 and the 4 back in when I get all done. So if I look at 6 and 5, the first number that they both go into is 30. Which means to get from 5 to 30, I'd have to multiply by 6 on both the top and the bottom. So 4 times 6 is 24. On the bottom, to get from 6 to 30, I'm going to multiply by 5. So 5 times 5 is 25. And then I'm going to bring my 1 and 4 back over. Now my job really is going to be focusing on solving from using this column. So if I'm going to solve now from this column, 30 is the bottom number for both of these. It's going to be the bottom number over here. 24 and 25 added together would be 49. And 1 and 4 is going to be 5. Now, good, because now we've kindly gotten it together, but part of our issue is here that this number is bigger than this one. So it's kind of like having more than $1 in change. So I need to figure out how to change this part into, you know, however many dollars will go into from the 30 to the 49 and add that to the 5 that's already there. So I'm just going to go off on the side here and I'm going to do what we did before. I'm going to take my 49 and I'm going to divide it by 30. So it would go in there once, oops, with 19 left over. Now I want to use the check mark method like we were doing before, which means now this number right here, this 49 over 30, is really equal to 1 and 19 over 30. But I have a 5 that's already here. So that 5 and 1 together would give me 6. And then it would be 19 over 30. Now the good thing for us is that 19 is actually one of those numbers that was one of the big 8 prime numbers. So because that doesn't go evenly into 30 and doesn't have anything in common, that's going to be our final answer. Okay, now subtraction works the same way. Still have to get the same bottom number there. So on this one, I have 14 and 7. And 14 would be the number that both of these would go into. Smallest one that they both go into evenly. So to get from 14 to 14, that's just like multiplying by 1. So that's going to be 8. And this is going to be multiplying by 2. So that's going to be 2. And then again, we are going to work on solving from this column, because that's where everything is kind of together. So if I do this one, 8, oh, let's do the bottom number first. 14 and 14 gives me a bottom number of 14. 8 minus 2 would be 6. So really what you're doing here is it's this minus this is going to give me this. Now, we do have to consider, can you reduce this? And I can kind of see that 2 could go into both of these. So 2 would go into 6 3 times, and into 14 7 times. So 3 over 7 is going to be our final answer. Okay, let's try it now with some mixed numbers. So if I look at this one, 3 and 5 are my bottom numbers. So remember, as soon as I see the mixed number, that's where I skip a little space and go over here and make my number line, or make my line for my fraction. Same thing down here. The smallest number that 3 and 5 will both go into is 15. That means to get from 3 to 15, I would multiply by 5. So 2 multiplied by 5 is 10. And 9 is my number in front. Now if I make 15 the bottom number here, multiply by 3. 5 times 3 is 15. 3 times 1 is 3. And a 3 out in front. Now, this is going to be about just putting our stuff together. So 15 will be our bottom number. And remember what we did before. This minus this is going to give me this. So 10 minus 3 would be 7. 9 minus 3 is 6. Now 7's one of those big 8 prime numbers. So unless 7 goes into 15 evenly, which it doesn't do, this is our final answer. Okay, now this is one that we really need to pay attention to. And I'm going to add this across the top because this is a borrowing problem. So now it's a borrowing problem. So this is one where we will need to borrow on the top because there isn't enough to subtract the bottom. Now I'm going to pull this so it can kind of go off to the side here, but I want you to kind of keep that in mind as we go through this next part, because that's going to be really what gives us information about what to do when we get stuck. And believe me, this is a section where some of you are going to get stuck, so it's important to kind of remember that. So first of all, let's start out like we did the other ones, and we're actually going to go through and find our common denominator. So in this one, I'm going to skip a little space and make my line. Skip a little space and make my line. And 22 and 11, the smallest number that 22 and 11 will both go into is 22. So on the bottom, multiply by 1, which will give you 7 here, and then 3. This one is going to be a multiplying by 2, which will give me 14 here and 1 here. Now, let me just talk about borrowing again. They have the same bottom number of 22. That's not my issue. But I can't take 14 away from 7. So in order to solve this problem, I have to borrow. The only place I can borrow from is this 2 out in front, or this 3 in front. So 3 is going to become a 2. Then in order to get this fraction to be bigger, I'm going to have to add something to it. Now when I add, I have to base on the fact that I want 22 to be in the bottom. I don't want to find another common denominator. That's going to make me crazy. So I need to keep that. Remember, if I borrow 1, then the fraction I add has to be equal to 1. And remember, any number over itself is equal to 1. So on the top, it now becomes 2. 22 is my bottom number. And 7 and 22 would be 29. And then I'm going to bring the bottom part over. Now the good thing is, this is where we're going to solve stuff from. So 22 is my bottom number. And then I'm going to go through subtracting those two to get this. So on this one, 29 minus 14 is going to be 15. 2 minus 1 is 1. Now, my only issue in this problem is, can I reduce this? And I can't. When I think of 15, I think of 3 and 5. When I think of 22, I think of 2 and 11, neither of which have anything in common. So that's going to be our final answer. Okay, now, order of operations is kind of our next piece. Remember the please excuse my dear Aunt Sally. So parentheses in this one are really for this fraction to be with this exponent. So there's really not true parentheses in this one. So I'm going to check that off. If I do exponents, 6 over 7 squared would be 6 over 7 times 6 over 7. So 6 times 6 is 36. And 7 times 7 is 49. And I'm going to bring this first part of the problem down. My exponents are done. So the next on my list to deal with is multiplication and division. And that's really all that's left. So this will be the last part I need to do. Now remember, look diagonally to see if you can reduce. These two don't reduce, but these two both have a 36. So 36 will go into itself once for both of these. So 1 over 49 will be all that's left over. And that's our final answer. Okay, now multiplying and dividing was checked off. Remember, there's no adding and subtracting, so that's taken care of. Let's try one more order of operations here. Please excuse my dear Aunt Sally. So in this one, there's no parentheses or exponents, and it's all multiply and divide. So remember, we start with the first pair on our left and work our way to the right. So on the first one, 45 over 15 divided by 11 over 8. So remember, this is the one where you do, when you divide, you don't ask why. You simply flip the second guy. So this first one stays just the way it is. And the second one becomes 8 over 11. Now reduce if we can. 8 and 15 I can't do anything with, but 11 and 44, 11 will go into both of those numbers. So 11 will go into 44 4 times, into itself once. So this would become 4 times 8, which is 32, and 15 times 1 is 15. And then I'm going to bring this part of the problem down. Okay. Now if I look at this, I'm going to reduce again. 5 and 15 both have a 5 in common. I'll go in here 3 times and here once. This 8 will go into itself once and into here 4 times. So basically I'm left with 4 over 3, which is equal to 1 1/3. No reducing necessary.